Right. I'm here today to give the physical component of the network, connecting the actual end user through a network or a security infrastructure to the cloud, your private data center, to your SaaS apps, wherever that may be. What you have to consider, and what is the impact of AI and automation having on network and security ops? So just to start things off, these are kind of just redundant slides, but I think they're kind of interesting. That the world we're heading into is everything is connected. Insight driven by algorithms everywhere, and everything is digitized, whether it's your physical body, whether it's machines, everything's done so we can analyze best ways to do things with that unlimited compute available to us in the cloud with AI. And just some examples of this recently, which for some of this crowd will be not too earth-shattering, but I think they're just showing it when you take an enterprise and you're trying to design a network and security infrastructure to support all the things you may not be even thinking of yet. For instance, Ring's coming out with their always home cam drone, so that you can fly a cam drone around your house if you have a water leak. That'll be coming out next year. We were talking about Chat GPT today at OpenAI Foundation. And when you're trying to be a planner, a network architect, a security architect, particularly from the edge where all your users could be at home, they could be on your campus, they could be at a branch office, they could be anywhere. What's that vision got to look like to optimize your automation to drive your costs out and get that expertise that's harder and harder to find every day? I like the Steve Jobs quotes there. A lot of times people don't know what they want until you can show it to them, and that may be particularly the case nowadays with everybody head down and trying to stay on top of their job. But then the other thing that has to happen is you have to have performance, and a lot of the AI ops focus nowadays, particularly around network and security, is providing those services, but providing them consistently based on the applications and making sure that they are focusing well. Until they aren't focusing well, everybody's experienced the collaboration meeting where someone drops off or they can't hear them, and that's a problem that all these operational teams are trying to address. Another thing is you look at where the world's headed. It's headed to the Web 3.0, where it's a distributed world that's intelligent. Just to show my age, that's when Synercomm started back in the 1990s, just after the age of the dial-in modems, and then we went through the on-premise servers with the north and south traffic from your data centers, and then we went from DOS to Windows, and then through modern day, where we've got a lot of the tools that have been around forever. Office is now in the cloud. You've got public clouds. You've got a lot of SaaS operations. You got IoT, and you've got everything's pretty much wireless connected, but yet you still have mainframes around and the smartphone driven with the browser. And now we got the Chat GPTs. People, because of COVID, have very sophisticated homework environments, and now you're having to plan a network that can support applications that are very distributed, like Ethereum, Bitcoin type interfaces. The strategy to prepare for the future is you dump things into data lakes like we've been talking about, and then you start applying algorithms to try and pull insight out of those. So it's kind of the world where it's been, and with the net ops people and security ops people have been dealing with, and the architects. Then we're trying to head towards that utopia of the AI ops, where the network and the security infrastructure gets smarter and smarter over time, and lets us spend more time focusing on the higher level challenges. So network infrastructure, if you think about that, in the days of when we first hooked up the infrastructure, it was pretty much stateless. You put security on the network, you allow it on redundant connections. Any path through the network is where things started back in the days of web browsers. And now we're into the day of, we've got all kinds of tools to enable all these advanced applications we have now, where you have security in the network, you have load sharing devices in the network, you have overlays to get through the network. So you have all these layers of obfuscation. And what do you do to start automating and making that more, removing the complexity and having the network take care of itself? Step one that a lot of people can do right now is automate your subject matter expert, network engineer, environmental knowledge. Take that knowledge, take the time, go back, study your trouble tickets over the last 3 months, 6 months, and see what kind of repetitive troubles that high-end engineers are getting dragged into, and look for ways to automate that put some examples of the best of breed tools, so that if you want to do further research, I got a short list for you. Like NetBrain is out there and does a lot of that automation, network design, validation, and allows you to really automate a lot of those steps that were done manually. And then as far as the AI impact, one area I want to focus on is just a use case here in my short amount of time is the Gartner Magic Quadrant for wired and wireless LAN. There's been an AI paradigm shift that started back in the 2014 days, and it's very interesting. I think it can be applied to all different domains of networking and or security, and I'll go through a security example after this. But I'm going to use Juniper, the Mist networks for that, and it really took a different level of thinking to solve this problem at a higher level. Basically, networks, Wi-Fi, enterprise Wi-Fi solutions at that time were specifically managing devices and traffic levels like protocols on those networks, and not really the user experience. And so the paradigm shift was, what would we have to be able to collect for data to measure the user experience, and also particularly what application information and user session IDs and things we have to monitor. So we'd have to change the network fundamentally from managing devices as up or down, managing user experiences, and managing protocols and traffic to applications and users to make sure we can find the best paths and prioritize the right sessions that require real time. So what that was is really domain specific network operations or machine learning and AI. And really, there's a couple of aspects of that that really have made life easier and allow people to focus on more important events, especially in this distributed world we're working in with people all over the place. Reactionary inputs are things like, I'm on my Teams meeting, we're on the Zoom meeting, and all of a sudden it starts going bad. Is it, is the root cause a bad uplink? Is it the application issue? Is there some kind of an ISP outage? That's an example of reactive. What's wrong now? And pulling that root cause information together in a way that is very concise and allows people to get the information they need quickly, which also there's proactive component to this, which is proactively leveraging this data you're collecting and coming up with things like, oh, there's a bad cable, which is causing errors in the network. People have been troubleshooting the application, they've been troubleshooting the user device, and they find out it's a bad physical cable. So also, as part of this AI revolution and the domain-specific Wi-Fi apps, there's now the conversational, which is like the Chat GPT virtual network assistant, which you can ask questions like, what happened to my network yesterday? Why did my Zoom meeting not work appropriately? And they call that Marvis in the Juniper world. So that, again, gives you some reference if you want to look into this. But this is one of those paradigm shifts of significance where we went from managing devices to users. And then also, I think back in the days of security where you went, like Palo Alto went from monitoring ports and IP addresses to monitoring applications. And the vision for the future for this and for all these solutions is really a self-driving network. As more and more over time, they get more and more ability to self-heal themselves. And the journey to get there is not as simple as it sounds. You mentioned that started in 2014. The algorithms have been around for a while, but the art is taking all those algorithms and putting them together, their forecasting and prediction capabilities to put together to create meaningful insight that you can actually use to self-heal your network. And again, where this is all headed in the future is that self-driving network, but not just across a domain like the wired and wireless LAN, but also across the WAN access, the data center, and the cloud domains, and tying that all together into multi-domain artificial intelligence. And that's the future race that everybody's trying to enter and how to do that very effectively. So now I'm going to switch over to the security ops. And here we've got, I just want to clarify what we're focusing on. When you have the life cycle of security, you really have things like detecting, preventing things from happening on your network, detecting things that did happen, and if they did happen, how do you respond? We're going to talk about focusing on the identify controls, the detect controls, and the protect controls of the NIST cybersecurity framework. We leave the recovery and response. That's a different topic. That's handled generally through lawyers and incident responders, but that'll be out of scope for what we're focusing on here. So in order to understand why security is so difficult, in order of magnitude beyond even the networking optimization, is just to look at an application is really built out of three components. You have processing, networking, and storage. And those components can be either centralized on your computer with a bus connecting storage to the processing and the applications, or decentralized, like we mentioned, things like Bitcoin and all those types of applications that are distributed across the world. And then you have to overlay security on all these, which security, the identity and access management frameworks for the authentication, authorization, and accounting of those connections. And the big word in security now is zero trust. We're going from take things off the internet that don't have to be seen until we can validate who somebody is, to make that attack surface a lot smaller. So why is security difficult? Then in summary here is we've got more and more attack surfaces and technology stacks with the Internet of Things. We have the clouds, we have premises, we have servers, we have just lots and lots of technology stacks that can be attacked. But also a malicious behavior, a security threat, is more than just, it's not just an event that you have to catch in a log. It's actually a series of events. For instance, if an administrator logs into your computer and tries to and logs in as an administrator, that's not necessarily a security event. But if they try and do something like a privilege escalation, lateral movement, that might now be a security event. So now we're going to talk first about security domain specific controls that can catch those types of things. But now that's only a certain series of attacks. How do you take that even further across all security domains? So where is security infrastructure? What are we looking at today? So today we're looking at a combination here on this slide of security and networking technologies. In general, we have on-premise in your offices, your branch offices, you're going to have some kind of a wired and wireless LAN, and then you're going to have some connections into the cloud of the world. And then you have people at home, then you have operational technologies like industrial controllers and things that need to get out. And they need to attach where? They need to attach to things like your SaaS apps, your Microsoft Office 365s, your ServiceNows, your public clouds. They need to differentiate between those connections. And they need to have private data centers, which are also have their role in life. And so how have the security infrastructure evolved to try and address these more complex requirements? One is, like we said, the identity and access management, accessing different resources, either in the cloud or SaaS apps or data center, has gone from a trust and verify with a login to a zero trust model, where you have to validate the person based on to interrogate them to different levels based on the confidentiality of what they're accessing. And it's also gone from point in time validation to continuous validation. And controls, because security remains such a big issue, have evolved. For instance, user awareness training now is going from training you sit down with like a KnowBe4 to a point where now you basically it'll watch the feedback it's getting from your security controls, and it'll tell a user that, hey, this site looks bad. So it's going in band and warning people actually in real time to try and prevent incidents. We all know that many of the incidents that happen with security start by tricking a user through phishing techniques and other things like that. The next thing is we've gone initially, because of the password enforcements and people not using strong passwords, MFA, but if you have a bad implementation of MFA, that can also create problems, because people can trick people into thinking they've got a request and then stealing their authentication. So now it's evolved to phishing resistant MFA. And the end node detection and response has gone from the old days of antivirus looking for signatures to then the EPP suites were binary yes, no type things. You could whitelist people, only let certain processes run, but they'll become unusable at some point. And that's where we've gone to the behavioral-based EDR solutions, or end node detection and response, which you can see all these are now conditional, so that makes determining information that is right and wrong much more difficult. And then today, we have a separation to think of all the branches in the world, or the access layers, whether it's your office, branch, work from home, that you have basically, you have your SD-WAN, or your connection to a service provider to get to the internet. And then you have your security on top of that, which would be the general Gartner Magic Quadrant name for that is security service edge, resides in the cloud, but has to be able to allow you to do things like very specific functions generally today. Some things may be really good at being a web gateway or content filtering gateway. Some might be good at allowing remote access. But we'll find here in a second that part of the challenge is what do you do to collect that information in a way that it makes it more usable to identify and validate things are going right. So what is the strategy that security teams have been taking is really, we'll get to that in a second, but the ability to collect logs across multiple domains, we'll call them of expertise, has been around for years. They've talked about SIM, which is Security Incident and Event Management Systems. The idea being you send all your events to the centralized system, and then you have to it collects your logs for compliance purposes, but then also can sort through them and look at for events. But it's very hard to do at the scale of most organizations. So then, like we talked about with the networking side, where we come with automating the subject matter expert, that's what the SOAR does. Security automation, orchestration, automation, and response type tools that all the leading vendors have to try and automate findings, again, based on what types of events that are repetitive are taking time. And the vision that now that you've also seen pop out now is XDR type pieces with some of the successes of the end node detection and response tools. How can I extend that across my entire universe of security? So what's the strategy we're seeing is people are taking that subject matter expert environmental knowledge and automating that with SOAR. And then now we've seen lots of success of examples of domain-specific security operations. Back a decade ago, Palo Alto really changed the rules on their specific domain with their application layer firewall. So went from, again, ports and IP addresses to users and applications from a network perspective. And then CrowdStrike and Microsoft Defender have really changed a lot of the world on the end node, particularly the Windows end node, and in order to protect and understand those behaviors and be able to identify malicious activity, and not in a binary yes/no fashion, but based on behaviors. And that's all heading down that path. So the future where security ops are now heading is the multiple domain XDR. And just to show you what that looks like, again, this is a Gartner slide of showing all the different components of an XDR security infrastructure, and then the front end and the back end. Like we had talked about, all these newer technologies on the back end are cloud delivered. They're pulling data into data lakes. They're doing advanced analytics to look for issues that only can be done in the cloud. And what makes this a challenging decision at this point for a lot of people is there's lots of different components on the XDR front end in there, where Gartner's issued magic quadrants for every one of those areas within the last year or two, and they all have different leaders. For instance, Active Directory, obviously, for identity and access management. You also hear of like Okta for identity and access management, with Active Directory being generally the source of truth for the whole enterprise. Then you have the network attachment piece, which is we talked about the Palo Alto on the network side, and now the Zscalers in response to delivered from the cloud for the cloud. Whereas Palo Alto has started on the edge in the firewall, the network, and now has moved its way. So these things are all starting to overlap. And then on the end node, things like CrowdStrike, Microsoft Defender really have dominated that end node EDR market. And they're all trying to build out pieces of the puzzle. But the question is, how do you slice that pie? Where does EDR turn into XDR? And, how does Palo Alto feed into that? And what pieces of these solutions do you need to execute cost effectively while automating, again, first steps with like SOAR on the security side, and then network engineering expertise on the network side. And part of SOAR, part of XDR is combining, part of the criteria is combining the networking with the actually security controls. So the question is, do you need a separate SD-WAN connection, which controls your multiple links to the internet to give you the resiliency and the traffic flow you need? Or can all that be integrated with the security components and all these different parts that you might need? And today, there's no one that is best of breed for all of that. We have the networking people that are really good at the networking. We have the security people that are really good at their parts of security. And the utopia is heading towards that appliance that can do everything good enough to and correlate everything between all those different platforms, or their own platform. That's where everybody is headed.
Hey, Kirk.
Yes.
Kirk, we've got a few minutes left. So I just want to ask you, if you can, to summarize for all the attendees, what should they do perhaps differently? And given this changing landscape, what can Synercomm do to help them get to this holy grail single appliance?
Yep. Well, the first question is, your security teams, are they your security and network operations teams? They have to define who's going to control what. For instance, today, firewall people, the network teams a lot of times run the firewalls, whereas the security people run the policies in the firewalls. So you have to define at the edge now, what do I actually need? So start on the front end, and that's one of the services we provide here is that needs analysis architecture. Is my resiliency of my network and best of breed, pulling in those best of breed partners like we see here that really are their best of breed for a reason, or can I get by with one overall platform based on how many branches I have, what kind of connectivity I have, how critical that is. And then once you understand how you're going to play on the edge, then tie that back with the core. And that can all be done through really having getting the networking teams and the security teams working together on that infrastructure now as we combine not just firewalls, but also the other components of security on the edge and tying that all together. So Synercomm does that. We have an application actually that we developed called our attack surface management application that helps people understand what is their publicly accessible attack surface and does it change over time, and that continuous monitoring, as well as we work with a lot of these leading technology providers, and we do lots of experience in Fortune 500 type organizations, integrating like the networking of Juniper with Palo Alto and CrowdStrike and Infoblox on DNS, and tying all that together in the most cost-effective way while moving forward by automating and letting people spend their time on more valuable topics. Couple reference resources here at the end that I always like is Roger Grime put a plug in for him here. He's got a book that's 50,000 copies sold of a data-driven computer defense, which really helps people wade through all these options and come to what's really mission critical in their environment. And then the future is faster than you think, with Peter Damadeus and Stephen Kohler just talking about all these exponential technologies, and they're coming together. If people are interested in any of that, they can contact us. I have the links there. We offer free attack surface management trial, which people can see if they have anything in their attack surface they're not aware of, whether that resides in the cloud, whether that resides in a hosting center, wherever that might reside, or it's so that's one area that we can help you get a handle on things. And then we also have a password assessment where people can use basically we assess the passwords for like reuse, so that if someone does get access to your passwords, they cannot, you'll understand what your security posture of like your password infrastructure is in Active Directory. And that is it. So anybody back to you, Ron.